Okay, in our next section, 10.2, we're going to continue with this idea of solving the quadratic equations. And so far, you have seen two ways that we have done this. You may recall from chapter 7, if we have an equation like x squared minus 6x minus 27 equals 0, well, here we cannot use the method that we learned in our last section, 10.1, the square root method, because we don't have just a squared quantity and a number quantity. This linear x term in the middle prevents us from using the square root method. So we would have to rely on our previous method that we learned back in chapter 7, and that of course would be to factor. Okay? And this is nice and factorable, in which case now we would have an x and an x. We know we would have different signs, plus and a minus. And then we would need, of course, the factors of a negative 27 that would add up to a negative 6. And that, of course, would be a negative 9 and a positive 3. And so now the zero product property would allow us to set each factor equal to 0. And when we solve for x, we in fact get negative 3 as well as a positive 9. Those were the two solutions that we were able to get using that method that we learned back in chapter 7 when we were asked to solve quadratic equations. And at that point, the only method that we knew was by way of factoring. Okay? And like I said, here we cannot use the square root method. So let me just write that down. That you can't use the, I'll abbreviate, square root method because of that negative 6x in the middle. Whenever you have an x term in the middle, you can't use the square root method, okay? Only when you have a squared quantity and a numerical quantity. For example, let's say we had x squared plus 8 equals 0. Now here, you can't factor over the real number system. Okay, this is not factorable. So that's why the other day you learned the lesson about the square root method. Okay, so here we are going to use the square root method because we have a squared quantity and we have the numerical quantity, which means, of course, we would want to begin by subtracting 8, in which case now we would have an x squared equals a negative 8. And so now, of course, to eliminate the squared x on the left side, we would take the square root of both sides. And don't forget, when you take the square root of the numerical side on the right, you put plus minus. And so now we're going to have x equals, well, let's take a look at simplifying this radical. We know we're going to have a plus minus. If I was to pull apart that square root of 8, I might use my factors like the square root of 4, the square root of 2, and the square root of a negative 1. And since the square root of 4 is 2, and the square root of negative 1 is I, and now we can't do anything with this remaining square root of 2, so that just comes along for the ride. And so our two solutions here would be a positive 2i square root of 2, as well as a negative 2i square root of 2. Okay, so here we saw two completely different kinds of problems. One where you had to factor and can't use the square root method. The other where you can't factor and you would have to use the square root method. So both methods are good methods, but they don't always work. So what if we wanted a way that always worked? If we wanted to limit ourselves to only learning one way of solving a quadratic equation, and you want to make sure that it's always going to work, whether it be a problem like the first or a problem like the second, we have a way that will allow us to solve quadratic equations. And it's a formula. And it's called the quadratic formula. And this formula you may have heard of before from a previous math class. It's a quite long formula that you'll have to know. It does involve a pretty big square root. And the quadratic formula looks something like this. X equals the opposite of b plus minus the square root of b squared minus 4 times a times c, all divided by 2a. That is your quadratic formula. Notice once again, I say that this is the opposite of b. Let me actually write that. The opposite of b, not just negative b, okay? The opposite of b, which means you have to change the sign of whatever b is. Plus or minus, now we have that big square root. B squared minus 4 times a times c. Everything that's underneath this radical is being combined together. B squared minus 4 times a times c. And then the entire thing gets divided by 2a. Now, what are these a, b, and c values that we are talking about here in the quadratic formula? Well, we can use this quadratic formula when our equation, our quadratic equation, looks something like this. And you've seen something like this already. We're going to have an ax squared plus bx plus c equals 0. So if your quadratic equation is in this form, where a is the number in front of the x squared term, b is the number in front of the x term, and c is the number that's all by itself. Now, a, b, and c are going to be numbers, whole numbers, actually integers, because they could be either positive or negative. And there is one value of a that could never happen. A can't be equal to the number 0. B could be equal to 0, and C could be equal to 0, but A, the number that's in front of x squared, can never be 0. Because if it was, then you would not even have an x squared term, because this whole thing would go away, and it would no longer be a quadratic equation. Okay? So, let's take a look once again at a problem. Actually, let's go back and do that same problem that we had where we did the factoring. Let me show you how we can use the quadratic formula to solve x squared minus 6x minus 27 equals 0. Okay? We already know what the answers to this equation are. We solved it earlier, and we got -3 and a +9. Okay, so I'm just going to write the solutions over here. X equals -3 and x equals a +9. Okay, so we already know what the solutions are, but I'm going to show you how this quadratic formula works. Okay, and that will actually get these two solutions. Let's start by identifying what is A, B, and C, so this way we can plug them into our quadratic formula. Well, remember, I said A is the number in front of the x squared. Well, if we look at our quadratic equation, the number that's in front of the x squared term, of course, is the understood number 1. B is the number that's being multiplied with the x term. In this particular case, -6 would be the value of b. And c is the number hanging out all by itself without a variable. And so as we can see here, c would actually have a value of -27. Okay, so now that we've identified a, b, and c, I'm going to take those numbers now and carefully substitute them into my quadratic formula. So x is going to equal Now remember, I need the opposite of b. Let's take a look. b is a negative 6, and if I need the opposite of that, that would be 6. Plus minus. Now here comes the big square root. Now I have to take b and square it. If I take my b value of negative 6 and square it, we get 36 minus 4 times a, which is 1, times c, which is a negative 27. And this has to be divided by 2 times a. So we plugged in the numbers into my quadratic formula for a, b, and c very carefully. All right? Watch your signs, okay? Now it's a matter of simplifying this as much as we possibly can. Let's start with what's underneath the radical. So I have the 6 plus or minus. Well, let's take a look here. If I was to go and do 36 minus 4 times the 1 times the negative 27, we get 144. That's what you get when you perform here the simplification of 36 minus 4 times 1 times the negative 27. You get a positive 144, and that, of course, is be divided by the number 2. Well, let's take a look now. The square root of 144. 144, we know that to be a perfect square. So now we have the square root of 144 is 12 divided by 2. Now let's see what we could do to simplify this even further. Well, we have 6 plus 12 divided by 2, as well as we have 6 minus 12 divided by 2. That's the two parts that we have here. Well, if 6 plus 12 is 18, and of course 18 divided by 2 is 9. There's one solution. If we take 6 and minus the 12, we get a negative 6. Divide that by 2, we get a negative 3. And if those two numbers sound familiar, they should. That's what we got originally when we solved it by factoring. So here, you actually had a choice. We could have solved this by factoring. That's one way to do this. Or we could use the quadratic formula. If you're not a fan of factoring, okay, quadratic formula will always work. That is the one way, that's the one method of solving quadratic equations that will always work. Factoring only sometimes works. And remember, we can only use the square root method when we have a squared quantity and a numerical quantity. So here, once again, we could not use the square root method. That's the one method here that wouldn't work. As good as the square root method is, it would not work for this particular equation. We could have solved it by factoring like we did when we first started the lesson, or now we can use this quadratic formula. Okay? Let's try another one. For example, let's say we have the following. X squared minus 7x plus 12 equals 0. Now once again, in this particular case, the square root method is out because we have this middle x term, the linear x term. Is this factorable? Well, I happen to know that it is. I'm comfortable enough with my factoring to recognize this as being factorable. But if you're not a fan of factoring, can't imagine why, you might want to resort to just using the quadratic formula. That's perfectly fine. Once again, let's start by identifying A, B, and C. A is the number 1, B would be the negative 7, and C would be the number 12. And so now, if we recall, x equals the opposite of b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. There's the formula once again. And now let's go and plug things into our formula, and let's see if we get the correct solution. X equals, well, the opposite of b, well, b is already negative 7, so we need to make it a positive 7. Plus minus, square root now. Now I have to take b and square it. Well, if b is a negative 7 squared would be a positive 49, minus 4 times a, which is 1, times c, 12, all divided by 2 times the number 1. Now let's take a look at this. Let's simplify as much as possible. X is going to equal 7 plus or minus. Let's work inside that square root for a moment. Let's take the 49 minus 4 times 1 times 12. Well, if I perform the simplification inside the radical, we would get we would get the number 1 over 2 times 1, which of course is 2. Now let's see what we could do to further simplify. 7 plus or minus, well, the square root of 1 is 1 over 2. So now what do I have but 7 plus 1 over 2, as well as I have 7 minus 1 over 2. Well, 7 plus 1 is 8, divided by 2 is 4. There's one solution. Next, we have 7 minus 1, which is 6 over 2, or the number 3. So those are the two solutions for this quadratic equation. Was this factorable? Sure. If I factored it down correctly, I would get x minus 4, x minus 3. Zero product property would, of course, tell us x equals 4 and x equals 3, as we saw when we did it using the quadratic formula. Okay, so either method works in this particular case. The one method that did not work, once again, is that square root method. You'll get to pick and choose whichever method you feel is most appropriate. Okay, don't limit yourself to one method. Okay, don't pick a favorite and then only use that method. Okay, the one method that will always work is the quadratic formula. Okay, so that's the one method that you guarantee need to know. Okay, because you'll always be able to resort and rely on the quadratic formula. If something is factorable and you are confident in your factoring skills, factor it. It might be easier than the quadratic formula. Or if you see something that involves the square root method, where it's only a quadratic term, a squared term, and a constant, okay, then you can use that square root method as we demonstrated earlier. Okay, but the square root method, like I said, only sometimes works. The one method, I cannot emphasize enough, the one method that will always work is the quadratic formula. Let's do another one. Let's say we have the following. Let's say we have the equation 2x squared plus 3x minus 1 equals 0. Now, I haven't said it yet, but I have said it in previous classes that, remember, the quadratic equation must always equal 0, okay? And so, let's take a look at this. I know right off the bat, by looking at it, the fact that I have this 3x term here, the square root method is out of the question. So I'm not even thinking about the square root method. Is this factorable? If it's factorable, I might consider factoring it, but I know that it's not factorable. Okay, so there's two of the three methods don't work. So here we have no choice. We have to use the quadratic formula. So let's start by identifying what a, b, and c are equal to. Well, now a is the number in front of the x squared term, the number 2. B is the number that's in front of the x term, the positive 3. And c is the number hanging out all by itself, the negative 1. Let's just recall the quadratic formula. And so we have, once again, x is equal to the opposite of b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. Now let's go and substitute our values for a, b, and c into our formula, and then we will look to simplify. So x is going to equal. Now I need, once again, the opposite of b. Well, since b is 3, its opposite would be negative 3. Plus minus square root. Now we need to take b and square it. Well, 3 squared, of course, is the number 9. Minus 4 times a, which is 2, times c, which is a negative 1, all divided by 2 times 2. Now let's see what we can do to further simplify this. X equals negative 3 plus or minus square root. Well, if I go now and I try to simplify what I can under the square root, 9 minus 4 times 2 times a negative 1, that would actually give us a positive 17, over 2 times 2, the number 4. Now, always look to see if you could simplify further. And here, I can't simplify the square root of 17. 17 is not a perfect square, nor does it contain any factors that are perfect squares that would allow me to simplify this. And since I can't simplify the radical any further, believe it or not, this is the two solutions. We have a negative 3 plus the square root of 17 divided by 4, and then we have negative 3 minus the square root of 17, all divided by 4. Those are your two solutions. Let me give you one to try. I'm going to post an equation, and let's see, pause the video, and then once you're done solving it, return. So once again, here's the equation that I'm going to want you to solve. 2x squared, a minus 7x plus 3 equals 0. So take a few minutes now, pause the video, solve it, and then come back when you're done. Okay. Once again, the square root method doesn't work because of the x term, the linear x term in the middle. Now, I am comfortable enough with my factoring that if I wanted to, I could factor this. This is factorable, okay? But since this is a lesson on the quadratic formula, let's actually go and use the quadratic formula. In which case, let's identify that a is the number 2, b would be a negative 7, and c would be the positive 3. Now, let's see what we can do here. Once again, I'm just going to recall the formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. It's a good idea to rewrite the formula when you solve the problem, just so you have a frame of reference. And now I'm going to plug things in. X is going to equal. The opposite of b would be a positive 7, plus minus the square root. Now I have to take that negative 7 and square it, 49, minus, now I have to plug in 4 times a, which is 2, times the c value, which is a positive 3, all divided by 2 times the number 2. So now that we have carefully plugged everything in, now it's going to be a matter of simplifying things as much as possible. And so now, I start with what's underneath the radical. X equals 7 plus or minus square root. Well, let's simplify what's underneath the radical. 49 minus 4 times 2 times 3. That would give us, of course, 25. Over 2 times 2, the number 4. Now let's simplify as much as we can. Under the radical, we have a perfect square. So that would now give us 7 plus or minus, the square root of 25 is 5, over 4. Now we could simplify this further, because I have 7 plus 5 on the top over 4, as well as I have 7 minus 5 on the top over 4. Well, since 7 plus 5 is 12, 12 divided by 4 is, of course, the number 3. There's one solution. Next, we take 7 minus 5, that's 2. And 2 over 4, that's going to simplify to the fraction 1/2. So those would be the two solutions to this quadratic equation. Okay? The fact that I got rational numbers as my solution tells me that this was factorable. And let me just show you the fact that it is factorable. If we were to factor this down, you would get a 2x and an x. We, of course, know that we're going to have the same sign, two negative numbers. And so what would be the factors of 3 that would add up to a negative 7? That would be a negative 1 and a negative 3 here. And so now zero product property, we would still get x equals 1/2 and x equals 3. Same two solutions by factoring. So once again, you'll be able to pick and choose which method you feel the most comfortable with. Factoring, remember, only works when things are factorable. Square root method only works when we have a squared quantity and a numerical quantity. No linear terms, no x terms. Okay. Let's just take a look at one more equation. And then I have one other thing to show you that has absolutely nothing to do with solving quadratic equations. Let's take a moment and solve 8x squared plus 6x plus 5 equals 0. Let's see how far we're going to have to take this. Now, we start off by identifying that a is the number 8. B, of course, would be 6, and C would be the number 5. Once again, if I look at my formula, x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now remember, once again, we're going to now take those numbers that we had, and what we're going to have to do is we will have to substitute them carefully into our formula. And so let's see. We need x is going to equal the opposite of b, negative 6, plus minus the square root. Now we need to take b and square it. That's 36, minus 4 times a, which of course is the number 8, times c, which of course is the number 5. And now, once again, we're going to try to divide this. Don't forget about that. 2 times my a value, which is still 8. Now we have to carefully simplify this as much as we possibly can. Okay, let's see what that's going to give us. X is going to equal negative 6 plus or minus the square root. Now let's take a moment and carefully simplify what's underneath the square root symbol here. Okay, so if we do 36 minus 4 times 8 times 5, we get a negative 124 over 2 times 8, which of course is 16. Now we want to simplify this as much as we possibly can. There's a lot going on here. We can't leave our answer like this. Now, first of all, let's take a look at what's underneath the radical. I have this negative number. we know that we can't have a negative in our final answer involving radicals. So that means we have to incorporate the imaginary unit I. And the number 124, that could be simplified. I'm going to think of the square root of a negative 124 as the square root of, let's say, 4 times the square root of 31 times the square root of negative 1. Because 4 times 31 times the negative 1 would give us the negative 124. Now let's see what we could do to further simplify. X is going to equal negative 6 plus or minus. Well, the square root of 4 is the number 2, of course. And the square root of negative 1, that's the imaginary unit I. Square root of 31, can't do anything with. Over 16. Now there's one more thing that we have to do here for our final answer. Let's take a look at all the numbers that are outside the radicals. I have a 6, a 2, and 16. And what do I notice about 6, 2, and 16? Well, they're all even numbers, which means that they are all divisible by 2. So that means those three numbers of 6, 2, and 16 can be simplified. And so we will. Negative 6 divided by 2 is a negative 3. Plus minus. 2i divided by 2 is simply I square root of 31. And the square root of 16 over here divided by 2 is, of course, the number 8. So those would be the two solutions to that particular problem. They are imaginary in nature because they involve that I imaginary unit. Okay. So those are the three ways to solve a quadratic equation. Once again, factoring, square root method, and now the last method that you just learned, the quadratic formula. The quadratic formula, once again, is the only method that works all of the time. Okay? There is one more thing in section 10.2 that I'm going to talk about. It is another formula that involves a pretty big radical, and that's why I combine this particular formula with the quadratic formula. And the formula that I'm talking about is called the distance formula. Now, the distance formula you may have heard of before, I'm not quite sure. The distance formula looks something like this. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's your distance formula. Now, what do we use this distance formula for? We can use this to find what we call the length of a segment given its two endpoints. And the two endpoints would be x sub 1, y sub 1, and x sub 2, y sub 2. So if we have a starting point and an ending point, and we were to connect those 2 points, we could find the length of the segment that combines those 2 points using this distance formula. For example, let me draw a coordinate plane. It's been a while since we've done one of these involving a coordinate plane. I couldn't give you this equation back when we did coordinates and slope and that old bit because we haven't learned about radicals just yet. So let's say we have the points 1, 1, and let's say the other point is 4, 5. Let me graph those points. Here we have the ordered pair 1, 1, and then we need 4, 5. here's the 2 points. Here's the point 1, 1, and here's the ordered pair for 4, 5. And if I was to connect those 2 dots, we form what we call a segment. And we can find the length of that segment using this distance formula. I'm going to let 1, 1 be my x1, y1, and 4, 5 would be the x2, y2. And in order for us to find now the length of that segment, we're going to use the distance formula. That d equals, once again, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So I have my points x1, y1, x2, y2. I'm going to carefully plug them into my formula. I start with x sub 2. That has the value of 4. Minus x sub 1 has the value of 1. Quantity squared. Plus y sub 2 is the number 5. Minus y sub 1 happens to also be the number 1. Quantity squared. Now let's go and simplify things as much as we possibly can. Well, inside the parentheses, we have 4 minus 1, that's 3. And 3 squared, of course, gives us 9. Plus, then we simplify what's over here. 5 minus 1, that, of course, is the number 4. And 4 squared, of course, is 16. Well, let's add these two numbers together. Square root of 9 plus 16 is the same thing as the square root of 25. And we recognize 25. That's a nice perfect square. And the square root of 25 is 5. So the distance from the ordered pair 1, 1 to the second ordered pair of 4, 5 would be 5 units. Okay, we don't know what those units are, and it really doesn't make a difference. Could be inches, could be centimeters, could be meters, okay? But it's just going to be 5 units. And that's the distance formula, okay? Not a whole lot to it. It's just you have to simplify the radical as much as you possibly can, okay? That completes the lesson for 10.2, as well as the lesson for this Tuesday, April 7th, okay? According to the revised calendar that I emailed you, on April 7th, the focus would be 10.1 and 10.2. So make sure that you review these videos before attempting those homework problems. Thank you and be well.